Morning, Karim, and a big warm hello to all our listeners out there on this cold Thursday morning. I want to just thank you for making time to tune in to today's talk session. As mentioned, my name is Steve van Zyl. I'm the National Technical Manager for IOPSA. And before I kick off, I just want to remind our listeners not to miss out on an amazing and the biggest plumbing industry awards event that's going to be going down on the 28th of July, 2022. It's something that one really needs to experience, and it's a really fun event, and it's, as I said, it's one of those biggies, and it's something you don't want to miss out. So if you want to book your seat, please, or you need some more information on it, please make contact with our marketing division, which is marketing@iopsa.org. So today I'm basically going to be talking to our listeners about discharge pipes from valves. I often receive many calls and questions on how many elbows can I use on a discharge pipe? Is one allowed to use more than one elbow? And if so, what are those rules? And how do we apply those rules? Other questions that I also get are, for example, or they range from when do I upsize a discharge pipe? How do I do it? And from where do I upsize that discharge pipe? So with that being said, let's take a closer look at SANS 10254 5.2. And let's take some time and unpack reference A and reference B. So my aim today is just to try and make sure we get a nice, clear understanding of how to try and fulfill some of these questions. So if we look at SANS 10254 5.2, it makes reference to discharge from valves. It says the discharge pipes from expansion control, it's important, and safety valves shall. And shall is a definite, so it's got a definite function. You have to, there's not an if or maybe. So let's just take the first section, which you see I've highlighted in yellow. It says A, be of a size not less than the size of the connection to which they are fitted. So just if we stop at that point and if you glance your eyes, ladies and gents, down to the bottom, you'll see there's two pictures. So as we know, a TP valve, the connection of a TP valve is 22 mil. So that would be then obviously the size of the pipe size that it needs to be connected to, which is 22. So therefore, you can't reduce it to a 15 because reference says you may not make it. It needs to be the same size as the connection. If you look further down, it says that discharge pipe, it needs to be considered to a maximum, or says with due consideration to the fact that the maximum length of run is 4 meters. So that is where it stops at 4 meters, and that's the maximum length that you can apply on that 22 mil pipe that you see. You move to the next slide. I would like to just try and explain this a little bit more in detail. So what happens after 4 meters of run? That run, then obviously the standard says that it shall be increased over the whole length to a maximum of 9 meters. So as soon as you get to that 4 meters and you're still not out of the building to a safe place where that water can discharge or the steam can discharge from the TP valve, you need to obviously do something, and that says then you need to increase the size. So how do we do that? If you look at the photo, you'll see there that the top picture, the top TP, that has been increased to the next size because remember the length is 9 meters now. And that size is now all in 28 millimeters. Remember that if you look carefully back at the requirement, it says it shall be increased over the whole length to a maximum of 9 meters. So nothing more than 9 meters on 9 meters is where it says the maximum stops. So the bottom picture is something that we do come across, we often see, and that's not correct. So it doesn't say after 4 meters, you then increase or upsize over the balance of the TP discharge pipe. And that's why I've put a big little cross mark to say that's not correct. That's not the way to apply it. It definitely says over the entire or the whole length. So question I then obviously also need to maybe just stop on. The picture below is, or the question is, how do we then connect? I mean, how do you connect a 28 millimeter pipe to a connection that's 22? And ladies and gents, I've put a picture at the bottom just to show you that you're going to need a very small piece of 22 If the first circle basically just showing that that is a 22 mil copper pipe, and then basically a very short section, and then immediately upsize and then obviously increase in order to then conform to what the standard's saying. So when I say small, good practice would probably be about 100 millimeters, and then obviously all the elbows of the greater size, which is 28 millimeters. So section B in SANS 10.2.5.2 reads that they have to be 3 or fewer bends. And it then further says for each additional bend, and it's very important, for each additional bend, the maximum drain pipe length shall be reduced by 600 millimeters. So what is it saying to us? It's saying, well, I've got 4 meters. I'm allowed 3 elbows so that I can work with. That's the limit I've got. But should I choose, or I need to have an additional bend, a 45 bend, then I need to do something. And that something is that it reduces the maximum length that I have on my pipe. So if it was 4 meters, I'm going to reduce that by 600. In my next few slides, we'll basically talk us through a couple of examples in order for us to try and make that a clearer picture as to what are we trying to say, or what we're trying to achieve. So it also says all bends shall have a maximum of 45. So ladies and gents, no 90-degree bends are not allowed on a discharge pipe from the expansion control valve or from a safety valve. Let's move to the next slide. And here I'm going to try and explain how we apply this additional bends. So let's just have a look at it again. We're going to say for each additional bend, the maximum drain pipe length shall be reduced by 600. So plumbers and ladies and gents, note that you therefore can use more than 145 bend, but with a condition. You need to give up and, or some say shorten, or you're going to be reducing the discharge pipe by length of 600 millimeters. So if you're looking at the first picture, I know that I'm allowed 3 or fewer bends. The yellow section that you're seeing is I've tried to emulate basically a copper pipe. It was 4 meters, but I've added an additional bend. Therefore, I've reduced it by 600 millimeters. I only have then 3.4 meters of 22 mil copper pipe as far as the distance is concerned, or distance that is allowed now. Should I choose, and I need now to use an additional 2 45 bends, what then happens is that I know that once again I've got 3. I've got 4 meters, but remember that the reference is that it's got to be reduced by 600. So in this case, I'm using 2 additional bends. That means that it will be 2 times 600 that I need to deduct, which is 1.2. Therefore, I've only got 2.8 meters from my connection of my TP out, down and out of the building into an area where it will discharge safely as per all the other requirements that are within the standards. And then I've just given a third example, which I must say, we hardly ever see that people are using 6 elbows to get to a discharge point. But let's just have a look at it as an example. You've got your 3 that is allowed. I then need to reduce 600 per additional bend, which in this case is 1.8 meters. If you add it up, 3 times 600 is 1.8. And that would mean of the original 4 meters that I had, because I've added the additional bends, I only have 2.2 meters to work with. So let's have a look at some scenarios that you may come across. So I've tried to put it into a table. So if you look at the top, I've written here distance of 22 millimeter copper discharge from the TP connection to outside the building. So if I've measured from the TP to the outside, and I've measured exactly 4 meters, and I've used 3 bends, well, in this case, that would be perfect, and that would be okay, and that would be a pass or a fail, and that would definitely be a pass. If you look at scenario B here, you will see that the same distance, I've measured the same distance, which is 4 meters, but I've used a total of 4 bends. So 3 is allowed plus 1. Therefore, that's not, because I've measured 4 meters, it should have been 3.4. So therefore, I'm not conforming to what the standard's requiring. And unfortunately, that would be then a fail or incorrect. You look at C as another example. You'll see the distance that I've measured is 3.8. And I've also then used the 3 allowed plus the additional 1. As we said in the previous slide, I need to reduce by 600, and 3.8 is not where it is. It should be 3.4. So unfortunately, that is not a pass as well. That would definitely not conform. The other scenarios here, I've measured 2 meters on my TP discharge. I've only used one elbow. Well, that's perfect, as long as it's not a 90 degree, as we pointed out before. The other option is scenario E, where the discharge pipe is then obviously we're measuring 2.2. And here I know I've used 3, which is what standard says 3 or fewer, but I've used the 3 that I've got, and I've added an additional 2 that equals 5. And that is, if I do my calculation, so it's 2 times is 1.2. 2.2 is well within it. So there we go. That would then obviously then be perfect, or a pass, in other words. If you look at F as a scenario, let's say we did the same measurement once again. I measure 3.6, the outside of that building. From the TP, I've used 3 elbows plus 1 additional, which is 4. And that would not be correct. Let's quickly have a look at towards the end of reference to B. So obviously we've gone through that it must have 3 or fewer bends. For each additional bend, we've had a look at that. The maximum drain length shall be reduced by 600 millimeters, and all bends must have a maximum of 45, so no 90 degree bends. And then it says, or formed. Now, formed is something that you make, that you bend the copper pipe, and it says formed with a center radius of at least 5 times the diameter of the drain pipe. So how do we calculate that? So if we look at the diameter of a 22 mil copper pipe, we then say at least 5 times. So we take 5 times 22 millimeters, and we're looking at that center line, and that little red line that you see there, the center of that pipe, and that equates to 110 in this case. So a center line radius of 110. Guys, ladies and gents, sometimes can be very, very confusing. So what I have done is I've actually created a further slide just to try and illustrate the center line radius. Although we don't see a lot of people still forming the center line radius, but it is in the standard, and I do think it deserves a little bit of time just to quickly explain it. So let's just run through again. We've calculated that it's 5 times 22. So it's 110 millimeters at least. So that is what it's looking for. So that type of gentle bend, in other words, that's how you would calculate it for this specific drain pipe of 22 mil. So let's move to the next slide, and I hope to try and give you an example. So what I've done is I've taken 445 bends, and I've placed them as close, I apologize for that. And I've placed them as close as possible, as you can see from the picture. So as you see, it's using 445 bend. And when I mention a center radius, and I just want to see if I can quickly get a little keynote here. Just give me a second. I just want to get a spotlight or something that I can use. So if you're following this little marker, the center line radius would be something that's running in the center of the pipe, and it's making this kind of gentle bend. Now, if you consider the previous slide, and we took 5 times 22, which was 110, we are then saying that if it's more than 110, well, therefore, then it meets the requirement. And what I've just done in the example here, I've gone to the center of this bend, and I've basically calculated right to the other side, to the center, and it's approximately 120, and therefore, this would then obviously then conform, because it's more than 5 times that radius, as mentioned, as I said, 5 times the radius of the diameter, which is 110, which is what is required. And ladies and gents, that's basically, as I said, I'm trying to see any other way that I can try and explain this better. But it's normally it's formed at a long radius, and as I said, you need to meet the requirement, which is 5 times the diameter of the pipe. So common questions that I also receive is, well, Steve, what if the distance is more than the 9 meters? What do I do then? And, the other question I get is, must that TP be of metal? And the only way to try and explain to you is that the standard doesn't mention any further increase of size. And if I quickly just jump back to one of the slides where we reference it says here, the point of time is the size shall be increased over the whole length to a maximum of 9 meters. So the standard doesn't give you an extension as to say, for example, then you may do it or increase it even further. So some plumbers say, but Steve, what is there that one can do? Unfortunately, I don't have the power to say, well, you can go and upsize it again and again. You need to then obviously look at things like, maybe you could consider moving the geyser, changing the direction to maybe a closer point of exit. Some plumbers, in the roof space, they see, but if I just turn it this direction, I'm still conforming to everything in the standards, and it's actually a shorter distance. I'm not going to follow the previous plumber that maybe installed a geyser as an example. And there may be some other considerations. The only point that I want to make is that remember that when you do these kind of changes, make sure that other normative standards or requirements in the standards are met. Moving a geyser would maybe consider factors like, I'm moving the geyser, so I might be creating dead legs. There may be concerns with safety where you're discharging that versus where the old discharge point would have been. So ladies and gentlemen, just be aware that, you are conforming to other stuff. And, when considering moving geysers to try and achieve that discharge from a closer point, in other words. The other option would be where the standard makes reference where the provisions of a standard cannot be applied. So, for example, you need 10 meters, you've only got 9 meters. Well, then you may need to get a rational design regarding that, and there'll be some competent person that will work on the rational design. It's normally developed by a professional engineer, and those are, has to be some acceptable drawings that they have to consider and submit. And then those drawings obviously should never compromise the safety and performance of principles incorporated in any standard. Next question would be, obviously, Steve, must this TP pipe be in metal? Well, the standard is very, very clear. It says that in the case of safety valves, they always must be of metal and they must be inclined downwards away from the said valve. And with that, ladies and gents, I want to thank you for your attendance. I'm sure there's some questions out there, Karim. And if you need to get hold of me, ladies and gents, feel free to give me a call or even just drop me an email at technical@iopsa.org.
Yeah, thanks, Steve. I think if we can, look at something like that in the near future, because I think it's something that we come across fairly often in terms of that. But just thank you very much to everybody who joined us this morning, and to Karim and Steve. Have a wonderful day. Stay safe, and we'll chat next week. Thanks, Steve.
Great. Thank you, Karim, and thank you, Steve, and thanks to our audience once again.